Programming Throwdown, episode 61, Clojure, with special guest Eric Norman. Take it away, Jason.
Hey, everyone. If you're a longtime listener, you may remember we did an episode on Lisp almost 3 years ago, and we're coming back, and we're covering it in a lot of detail. One of the comments that we got when we did the Lisp episode from a lot of people was, hey, we want to learn more about Lisp, and here's some more details about Lisp, and things like that. This is before we really had a strong social network presence, where the only way you could really communicate was by emailing us. And so we got a lot of email about Lisp. And so we're really happy. Oh, go ahead, Patrick.
Yeah, we also briefly did mention Clojure we did like a collective episode of a bunch of JVM languages.
That's right. And so we mentioned Clojure by name there. And and so we have Eric Normand to talk in much more detail about Clojure and kind of really teach all of us a lot of really cool things about Clojure. So Eric, kind of tell us about yourself and what do you do?
Hi, my name is Eric Normand. My current tagline is I help people thrive with functional programming.
Nice.
I run a site called purelyfunctional.tv where I teach people Clojure. I want to expand it to other functional programming languages. And I basically teach with video and exercises and other online things.
Cool. What sort of inspired you to build that site and to teach people Clojure and other functional languages?
Well, it's evolved over time. I have always liked teaching. Well, always. I was a teacher in the Peace Corps, and I was teaching math. And when I got back, I kind of started missing it. I started programming again, and I started making videos and off and on. And then at some point, I did a Kickstarter to get some Clojure videos made, and that was a success. And just ever since then, I've been adding more and more videos.
Cool. Very cool. What is it like running a Kickstarter? I've funded several Kickstarters. I've never kickstarted anything. I mean, what was that process like?
So it wasn't that big of a deal. I think the biggest thing was beforehand, I talked to my friend who has funded a lot and kind of saw what worked and what didn't. I hadn't been active on Kickstarter at all. And so it was just a lot of discussions with him about what should I set my goal at? What should my rewards be? That kind of thing. And he helped me come up with the structure there.
Cool.
Yeah, I would say that my biggest advice for someone who's going to do a Kickstarter is take into account the marketing that you're going to do during the campaign. So I did mine for 30 days, which at that time was the default. I don't know what the default is now, but at that time it was default to 30 days. And so that's 30 days of you tweeting and promoting and just being generally on edge about whether you're going to make it and stuff. And if I were to do it again, I would probably cut it down to 10 days or 15 days. Because most of the backers came in at either the beginning or the end. And so if you just cut out the middle, then I would have had about the same amount. So
that makes sense. And one thing that I noticed is it's really, you have to, the audience wants to have faith in you, in you delivering on the Kickstarter. And so if you're messaging every single day, here's what I ate for breakfast today, I ate Clojure flavored Cheerios, then people know, okay, this person means business. And if I donate, that it's going to work out. And two, I'm donating to more than just a set of videos. It's a cause.
Yeah, for sure. It really helps to have an audience before you start. I think that's the number one failure reason is people don't have anybody who can listen, who knows, they're shouting into the void.
Yeah, that makes sense. So kind of explain, if you had to sort of explain functional programming to someone who's never heard it before, how do you sort of describe that? Let's say there's someone who, has taken some courses, they get C, and C++ really well, but they've never seen Lisp or Haskell or Clojure or any of these. How would you sort of explain that to them?
Yeah, so that's a really hard and complicated question because I don't think there is a very agreed upon definition of functional programming. But functional programming, for sure, comes from lambda calculus. And lambda calculus is a mathematics that uses nothing but functions. And so there's definitely the notion of using functions as your main form of abstraction. And functions are higher order. That means that they can be passed to other functions as arguments, and you can return functions from arguments. So functions are values that you can pass around. And languages like C, C++, you can kind of, like, let's take C because I know that a bit better. You can pass function pointers around and stuff, and people do interesting stuff with that. But they don't have what's called lexical closures. It's a technical term. It just means a function that can refer to variables that are defined where the function is defined. So like in JavaScript, if I have a variable defined, let's say variable A equals 1, and then I have a function defined right after that, then I can refer to A in the body of the function. You can't do that in C. So it becomes like you can't like capture the environment that it was in. So you can't really do the functional stuff.
Yep, that makes sense. So, I think one analogy is if you've ever played World of Warcraft or any of these, MMOs or mini games kind of like it, some of the weapons, in the beginning you get the wooden sword and like you just hit the rat over and over again. But then as you get better and better, you get one of these swords that has what's called a proc, which is short for a procedure. So it might be, when you hit somebody, there's a 10% chance of them turning into a chicken or something, right? And so, that process, like that event is sort of tied to that sword. Like you kind of want to assign the turning into a chicken to that weapon and be able to, if you give the weapon to someone else, you want to sort of give that logic to them too, right? And so I think, part of functional programming is this idea that like you can pass these functions around as sort of first class citizens. Yeah,
wow, that's a really great metaphor there.
Yeah, I played too much World of Warcraft.
Another way to look at it that I've heard about is, so you have, if you're familiar with object-oriented programming, you've got objects that have methods. So that's data with functions attached. Well, in a closure, in a lexical closure, like in a functional language, you have functions with data attached. So those that the variables that are defined in the scope are the data that you can access from that function.
Yeah, that makes sense. So that's functional programming, and we covered Lisp in the Lisp episode. But basically, what is Clojure? When we covered Clojure, we just very superficially said Clojure is Lisp on the JVM, but I'm sure it's much more than just that. Kind of how does Clojure fit into this whole landscape?
Good question. Well, Clojure is a Lisp for the JVM, and Lisp is cool because it's like a family. It's like it got dialects, and so Clojure is a dialect of Lisp that is made to be hosted on a virtual machine. And JVM is like the first virtual machine that it's hosted on. Oh,
I see. Is there something you can't do in Clojure because of that? Is there like, because it's a dialect of Lisp, is there some things that aren't there or are there that aren't in regular Lisp?
That's a good question. I mean, it's a different language than, say, Common Lisp. So there's a lot of stuff that comes with Common Lisp that is built into the language, whereas in Clojure, because it's designed to be hosted, it just relies on what the host can do.
Gotcha.
So I'll give an example. Common Lisp has this very sophisticated and like just a lot of features in the exception mechanism. So when you throw an exception, you can actually do what's called a restart. So you catch this exception and you can like fix the problem and then recall it and go right back to where the exception was thrown.
Oh.
So if like the file is not found, you can be like, oh, not found. Well, let me make it. And then you go right back into where it was, right?
Oh, cool.
Whereas in Java, and it's just built into the JVM, it's not part of the Java language, it's part of the virtual machine, the exception gets thrown and like the call stack gets unwound and it's lost. Like you can't go back to where you were.
Gotcha.
It's just, and so Clojure just kind of borrows all of that stuff from the host that it's on. So that includes like Clojure's numbers are just Java numbers. Clojure's strings are just Java strings. Functions in Clojure get compiled into a Java class. So, you know, all this stuff just becomes some concept on the JVM.
Gotcha. That makes sense. So I mean, how are some of these things like possible? Like in Java, you can't have closures, right? So I mean, I'm assuming Clojure can't be built in Java. It has to, like, in other words, like the concept of closures have to be added in machine code, I guess, to the JVM or something.
Well, actually, it's really interesting how it's implemented. So what most of the language is written in Java. Most of the data structures, most of like the logic and the compiler, it's all in Java. The way closures are implemented is like I said, there's a class, and when you have a new function that you're compiling, it extends that class, that function class.
Oh, I see.
And the function class has a bunch of methods on it. And each method is a different signature. So it'll have the 0 argument method, it'll have the 1 argument method, the 2 argument method, etc. And the class that it compiles to will extend those.
Gotcha.
And then all of the data in the closure, meaning the variables in the scope that it needs to access, get put into the class as member variables.
Okay, that makes sense. Yeah, that's very clever.
It's awesome. Clever, and like it's a way to, you know, use the function or the method call semantics of the JVM from, you know, without having to like invent some other mechanism. Right.
That makes sense. So so sort of, you know, for somebody who's maybe, you know, really into web development, or you've done a lot of maybe C++ kind of backend work, C++, Java, like why should they learn Clojure? You know, for someone who's already mastered, you know, one or two or several languages, like what, you know, we always talk about this metaphor of the toolbox and how there's not one sort of magic language. It's just the same as there's not one magic wrench that just does everything, or not one magic tool that just does everything. That's a wrench and a hammer and a, you know, whatever. And so, you know, if someone wants to, you know, assemble this sort of toolbox of languages that's sort of comprehensive, you know, what sort of does Clojure add to that toolbox?
That is a really great question. And It's something that I don't think is really fully answered. I can tell you, like, there's no general like one answer to satisfy that question. I'll tell you why I like it, and some also why people I know like it too. So when it first came out, the big story behind Clojure was that it handled concurrency really well. So the JVM has a lot of Java, the language has a lot of libraries and stuff for handling concurrency, and there's books written about how to do concurrency right on the JVM.
Yeah, it's very
the problem
hard.
is, yeah, it's hard. Like, you have to read this book and then do everything right, or you're going to get bugs.
Yeah.
And what Rich Hickey, the creator of Clojure, did is he took that book and basically built the language around that, so it works that way. Like, it's very hard to like not do it that way. So a lot of the primitives in the language, like, there's all sorts of stuff in Java, like you use the volatile keyword, and you have to you make stuff immutable and things like that. Like, all of that is just taken care of for you. So it has this really nice story of, like, concurrency is the default, and it works really easily right out of the box. And that is true, and it's really nice. And it's weird when I go to another language and I'm like, well, how do I do this at the same time? And like, oh, well, you can't, or you have to do this other completely like boilerplate system to get something else to run at the same time.
Yep. Yeah, that's a huge problem. I mean, what typically happens, you're building, especially if you're building an app for the desktop, you have some kind of UI, and the person specifies some files, and then you want to go off and do a bunch of work on those files, and it's almost always embarrassingly parallel. Like, very rarely do you need to do like just one, like, very sequential one thing at a time. Usually someone gives you kind of a batch of things to do. And in most languages like C++ and Java, this can get kind of quite painful.
Yeah, it gets painful because, like, all the pieces are there, right? Like, well, in Java, to make a thread, you just do new thread and you have a thread, and like, what's the problem? Well, that's only half the answer. The other half is, now that you've got this thread, how do you get information that it's calculating out back into the thread where you're going to display it on the UI, right?
Yeah.
And it's all these, like, ancillary problems, like, oh, well, maybe I need a queue. Okay, well, you're going to construct a thread and a queue and a thing, and like, it just never ends, right?
Yeah.
Whereas
totally.
in Clojure, it's as simple as, well, I'll just have, there's a bunch of different primitives. One of them is called an atom. And an atom is like the simplest kind of shared state. It's just one pointer that you can change, and you can have multiple threads accessing this pointer. You can read from it, or you can write to it, and it's thread safe. And I mean, this goes into, like, why one of the reasons I really like it is the focus of Clojure is on this simplicity of separating out all the different problems and solving them independently so that you can compose them back together. So you have the atom, and all it does is keeps one pointer and makes sure that whenever you transition from one state to the next, you're transitioning from a consistent state to another consistent state, like in a transaction.
Gotcha.
Right? You can't see it halfway done. And that is what allows multiple threads to read and write to it. I mean, really, with very little code. You don't have to deal with locks and stuff like that. It's all handled by the atom. And this simplicity of sort of here's the right tool for the job, and like the language just kind of gets out of your way. I really appreciate that.
Yeah, it makes sense. I mean, most of the time, you don't need to do these like hog wild things where you have 3 different threads all updating the UI at the same time. I mean, these things were important, in the 90s, but now it's like if you have 3 threads and each one locks the UI, updates it, and unlocks it, computers are fast enough where we don't need that level of control. And if you are willing to sacrifice the level of control, you could have a much cleaner language.
Yeah, for sure.
So most people want to build. I mean, there's people like Patrick who do crazy robotic stuff, homebrew stuff. He's got a drone firing lasers at people who come up to his house. But for the rest of us, like the other 99% of us, we're either building a website, a desktop app, which could include like a server that's serving web pages, or a mobile app like an iPhone app or an Android app. So can you do these 3 things, like any or all of these things in Clojure? How does that kind of work?
Yes, for sure. So the easiest one is the web app. Web apps have been done in Java for a long time. There's a thing in Java called servlet interface, and most of the Clojure web systems are some wrapper that uses the servlet API. There's the Clojure ecosystem, web ecosystem, is evolving right now, but for a long time, the main system was called Ring, and it was kind of like Rack in Ruby, and all it would do is it would take the request and turn it into a map, and it had a standard format. The request method was under a certain key, and it was a string, and then the port was a different key, and it was a number, and the body was so you could get this map, and then you did whatever you want with it, and then you would return a response. There's another map in a similar format, and then there's 3 concepts. There's the adapter, which is the thing that connects to the servlet API or whatever API you're using to do the web stuff. So that adapter connects to the API and converts requests into the Ring request, and then converts the Ring response back into an HTTP response. And then you have your handlers, which are functions from request to response, and then what's called middleware, which transform the request or the response as it passes through. So it actually transforms the handler into a new handler.
Yep, that makes sense.
So you would basically construct your web app out of these pieces. And like I said, it's evolving. Like, people are learning stuff. They want to do asynchronous stuff. Functions aren't great for doing like async calls. But that's still the main idea, is that you got this request map and a response map.
Yeah, that makes sense. So basically, all of the ideas, if you're used to doing Java, server-side web development, all of those ideas kind of translate almost one-to-one to Clojure. And someone has written adapters so you can kind of work in a completely Clojure environment and not have to worry about all of those bridges.
That's right. And it's to me, it feels much cleaner and, how do I put this? It's much more direct. So in like the servlet API, you get this request object that you like query, like, well, what, you call the method like get method, right?
Yep.
Which gives you the HTTP method and stuff like that. And so you really have to understand this API really well and like look up the docs. And then when you do the response, you have to like do set header and you're not supposed to call set header after you've like piped in the body, and like there's all sorts of like rules for how to use these things, and to me that's like really hard to keep track of.
Yeah, totally.
And so in Ring, the adapter is supposed to handle that. So you handle that one time, right? Like the adapter, once it's well written and conforms to the API and to the Ring spec, it's done. It's like you can just close that book and say, well, version whatever, it's done. And that's the kind of thing I really appreciate with the Clojure community. There's actually libraries that they're like, it's done, we finished. Nice. It's not like this continuing thing like, oh, well, we're trying to adapt it to this other situation so you don't have this problem, and we solved it.
Yeah, that totally makes sense. What about like mobile? If you're building an iPhone app or Android app, can you do that in Clojure?
So there's a couple of options. I don't think that this is being done so much anymore, but because the Clojure runs on the JVM, it can run on the Android JVM, the Dalvik JVM.
Okay.
But I think the most of the work now is in React Native.
Gotcha.
There was some stuff with PhoneGap. So we didn't talk about this, but Clojure also compiles to JavaScript. And I talked about it being hosted on the JVM. Well, another host that Clojure can run on is JavaScript.
Oh, nice.
And when it's compiled to JavaScript, it's called ClojureScript.
Oh,
it's
does it use
basically the same
V8 or
language.
SpiderMonkey or both?
I mean, it's whatever you want. It's JavaScript, so you can run it on any of the JavaScript
very
VMs.
Nice. That is super cool.
You can run on Node. You can run it, serve it through a web app and use it like whatever browser they've got. Run it. You can do React Native. You can do Electron. I mentioned PhoneGap. People have been doing that for a while.
That is quite remarkable. So if you I mean, JavaScript is very universal. But
for
if
sure.
you just let's say you just hate JavaScript, or you're programming something in a certain paradigm where a functional language would be much better, or at least Clojure would be much better, then you can actually write Clojure and it will compile or transpile down to JavaScript. That's pretty cool.
That's right. And you said the word transpile, and that's what it's doing. But a lot of times when people think transpile, they think CoffeeScript, and I have nothing against CoffeeScript, but one of CoffeeScript's like goals was to be just JavaScript but with better syntax, right? It's like you could kind of guess what JavaScript would be generated.
Yeah, I think they even have it's two-way. You can
convert it back. Oh, I didn't know that.
Or maybe it's sorry, it's not two-way, but there's a what's the word? Like there's a JavaScript compiler for CoffeeScript, and so there's actually on the CoffeeScript website you can paste CoffeeScript and it will turn it into JavaScript. You just right there on the website, and that's what I use CoffeeScript for taking other people's CoffeeScript and converting it to JavaScript.
I see. Yeah, and so that's a really, that's a valuable thing to do, is to like make the syntax better, because JavaScript can get pretty verbose. But ClojureScript is different. It really feels like a different language.
Oh, I see. And by that token, when you transpile it, you get JavaScript that's kind of unintelligible, because it's meant to be. It's almost like looking at assembly or something.
Right, exactly. So it doesn't do like asm.js. Functions compile into, Clojure functions compile into JavaScript functions. A lot of the if statements and stuff, like you could read them. What gets hairy is that the compiler does some optimizations. So what looks like a regular function call is actually going to turn into, in JavaScript, a dot call. Functions in JavaScript actually have methods, and one of them is dot call. And so when you're looking at the compiled code, it's like a little crazy because it doesn't look like you would write JavaScript at all.
Yeah, that makes sense.
But that's okay because the source mapping is all in there. So when you look at it in your like Chrome DevTools, you're looking at the Clojure script code, and you're getting line numbers from your Clojure script code, like through the whole stack trace.
Nice. Yeah, so source mapping, and maybe actually be amazing if you could explain it, because I have no idea how it works. But basically, I've used it for TypeScript, and what it does under the hood, I don't know. Hopefully, maybe Eric can educate all of us. But on the surface, you've written in TypeScript, but the person in the browser is still executing JavaScript. The person could be you. And when you get an error, you don't want it to just show you this completely unintelligible JavaScript. You want the error to actually redirect back to your code that you can actually modify. And the source map helps make that happen.
Yeah, for sure. That's a great explanation. It's like if you're gonna serve up some JavaScript, usually you're gonna minify it and like maybe uglify it. And so it's gonna be like one long line of JavaScript. And that's going to be impossible to debug. It's going to say line 1, like bugs on line 1.
Errors always on line 1.
Exactly. So they came up with this system, the browser makers came up with this system where you have this other file that's included along with it that gives you the ranges of code in that original file and the line that they correspond to in the original file, in the code that you wrote.
Gotcha.
And that works for JavaScript and CSS, I think, and because people minify that too.
Yeah.
And so it's really nice now because they've got it where you can put breakpoints. You can debug it and step through line by line, like what you think of as a line, because it's the code you wrote. Like you can put a breakpoint there and walk through line by line, even though it is compiled into some crazy JavaScript that you can't read.
Oh man, that's awesome.
Yeah,
I never actually knew you could do that. I always had unminified code when I was debugging. But yeah, I never needed to do that. That's cool.
Yeah, and that's actually largely thanks to one system that the Clojure script compiler uses. It's called the Google Clojure compiler, and that's Clojure with an S, Google Clojure.
Right.
The Clojure script compiler is a very simple, kind of naive compiler, but it outputs code that the Google Clojure compiler can read. The Google Clojure compiler is what Gmail is built in, and it does some really aggressive optimizations. There's different modes, but like when you're gonna release your code, like it does all this crazy optimizations on it, like totally analyzing code paths and like eliminating functions you don't call and things like that.
Yeah, just to sort of explain, because it's super confusing. So there's a Google Clojure compiler.
Yeah, I think the naming is really terrible.
Yeah, it's spelled with an S, and it has nothing to do with Clojure, at least directly. All it does is it takes JavaScript code and it makes it faster and more efficient. Just like you could have think of it as like an optimizer, right? You could have you could compile your code with -O. -O0, which no optimizations, or you can compile your code with -O3, and it produces, even though it's the same code, same logic, it produces a totally different binary, and that binary has all sorts of crazy, GCC optimizations, baked into it. And so Clojure is kind of like compiling with -O3, but it's in JavaScript, and so JavaScript goes in, JavaScript goes out, but the JavaScript that comes out is a much more efficient representation of what you originally intended. And that's different than Clojure with a J, which is what we're talking about. But you can actually use Clojure script with Clojure to produce, to write in Clojure and produce really fast JavaScript.
That's right. And I mean, it is some really cool technology. It's from Google. That's what they use to produce Gmail. And I mean, there's stuff like what's called splitting, module splitting, which means like, okay, so imagine you're developing this web app, and like your front page is going to have some JavaScript on it, but you don't have to be logged in to do it. And most people who go to that front page aren't going to log in. Then there's all the people who log in, and they're going to have this like rich web app experience, so a ton of JavaScript. And the thing is, you don't want to serve that big JavaScript to just the people who just go to the front page. So the idea behind splitting is that the compiler can analyze your code and figure out, well, the front page uses, this bit of code, the back end uses this bit of code, and then this bit of code is shared between the two. So you can cache that one that's shared between the two and only serve the homepage code and that shared code to the people who are visiting the front of your site.
Gotcha.
And then after they log in, they can get the rest of the code. So it's a way to like optimize the experience for, people who don't need that part of the code.
Cool. Yeah, that makes sense. I mean, one thing that people might not realize, there's an incredible amount of energy spent on making, especially the front page of any site, load very quickly. There's statistics that show for every, maybe 10 milliseconds, and of course it depends on different products and different sites, but for every 10 milliseconds that the front page takes to load, you lose, X percent of your customers, and it's like pretty significant. So if Clojure can kind of separate that and speed that up, it's awesome.
Yeah, and that's exactly the reason that people want to do it. It's just that speed of first load, but still provide some JavaScript, and then not having to the recommendations are to do all of that manually, like keep 2 files of JavaScript and keep that manually. That's crazy.
Yeah, it's way too much work.
Yeah, it's too much work. And so we've been talking about all this cool stuff we can do. The thing is, the development experience, in my opinion, is better than the JavaScript development experience. So it's not like it's, you get this great language, but then you've lost something because you have to have all this tooling and stuff. Let me give a little history. About 4 years ago, I was doing a lot of front-end development, back-end and front-end, but specifically I was working on like a JavaScript app. And 4 years ago, the space wasn't so developed. I don't think Angular was even out yet. Backbone was new. Like it was all this stuff.
Mm-hmm.
And we were using cat, the Unix command, to put different JavaScript files together.
Oh, no.
There was no Bower and Grunt. I don't even know what they are.
Yeah.
And so it was very simple times, and it worked. It worked. And then I went into ClojureScript, and I was doing the way you do it in ClojureScript, and ClojureScript was really new, so a lot of it was like raw, but it was evolving very quickly. And then I had to go back to JavaScript for another job, and I was just shocked. The number of tools you need and libraries, and oh, you're still using Grunt? You should be using Yank or whatever it's called, Yarn. NPM, like NPM didn't exist when I left JavaScript before. And it's like, it is just so crazy how many libraries and tools you need to develop nowadays in JavaScript. And
and it sounds like the Clojure script is easier to work with than Emscripten. So if you've ever used that, it's a total nightmare.
I don't even know what that is.
Oh, Emscripten is this thing where it takes C++ code and turns it into JavaScript. It actually goes through LLVM and then goes LLVM to JavaScript. And Zynga used it for all of their games. So the idea is
for games, yeah.
Yeah, if you play like Zynga Poker on your phone, that's almost all C++ code. There's just a little bit of iOS or Android code to handle the drawing and things like that. If you play Zynga Poker on, say, like Facebook.com or I don't know if even Zynga.com, but on the web version, that's also C++ code, the same code, but it's been translated to JavaScript with Emscripten. And talking to people who've worked at Zynga, it's just a total nightmare. I mean, if you have a bug in the C++ part, you just have to catch it on mobile. Like if there's some bug where if someone gets all 4 aces, it crashes or something, you just won't catch it on the web. Like it's lost. You just have to hope that you have that same bug on mobile.
Well, I mean, I'll tell you, I don't mean to bash on all these languages. I love languages; they're great. But I recently had to work in C++, and I don't know C++, so it's totally new to me. So I was already dealing with all of the novelty of everything. But the build system, I mean, we were just taking it took me over a week to get it to build on my machine. And I could imagine if then, you finally got it to build and now it's running in the browser and you don't have any way of source maps or, something like that to debug it. Oh man.
Yeah. I mean, it's a total nightmare. But you're totally right. Now things are a little bit better. There's Bazel, and there's Buck. Bazel's from Google, Buck is from Facebook. They're basically the same thing. But even then, they're not great. I mean,
even dependency management in C++ is still really bad. Oh
yeah, it's a total nightmare. If you want to pull, there's really no repository, not that I know of. There's not really a central repository of C++. I don't even know how that would work because you wouldn't be able to keep the binary because it's machine specific,
Right. Oh yeah. I don't even know where to begin with that. I'm not in that world and I'm glad I'm not.
But it sounds like Clojure script is better than that. It's more mature than that.
Oh yeah. Yeah. And I mean, the thing about JavaScript is it's a huge ecosystem. There's so many people in it. People are dissatisfied with their tools and they write new tools, but there's so much to keep up with. Every 6 months you have to rewrite your build system because it's not using the newest thing and you need a feature from the newest one or that's why in my personal website I use cat. I have a make file and I cat JavaScript together. And JavaScript is kind of like that. You can do that, right? You can just take 2 bits of JavaScript and smush them together and you have a bigger bit of JavaScript.
Yeah.
And I just don't, I guess I'm getting older. I just don't want to deal with these cycles of learning a tool and figuring out its JSON config format and I don't know.
Absolutely. I mean, when I was in high school, or I guess maybe college. Yeah, when I was in college, I got I got Gentoo. And for people who don't know, it takes about 18 hours to install, or at least at that time, it took about 18 hours to install Gentoo. Now, you don't have to be there for 18 hours, but it's kind of like you get in, you install the bootloader, you spend about an hour entering all these different commands to install the bootloader. And at the time, that was super cool because you feel like this, like Neo from the Matrix, like some crazy hacker.
Yeah, and Windows took a long time to install too.
Yeah. But in terms of like effort, Windows definitely took a while to, write to disk and all of that. But this was like, you have your bootloader, you'd reboot to the command line, like to just a root prompt. And sometimes, you'd do it wrong and you'd reboot and nothing would happen. And that was super, super fun at the time. But as soon as you become a professional and someone says, when is this going to be done? And you say a week. And then instead of taking 18 hours, it takes 30 hours to install your OS. You're kind of in big trouble. It is not fun anymore, And so, you immediately switch to, okay, I need something reliable, that's quick, that I could depend on.
Yeah, sure. I mean, I remember I used to be like in the 90s, I used to run Linux, and it was kind of the same as you were saying. Like, it would take this huge amount of time to like select your video card and make sure that X Windows would work with it and get all the settings right. There was no auto detect at that time. And then at some point, I would just be like, okay, enough. I need to check my email. Like, I would just like use the barest X there was. The barest X Windows. The one where you boot into X Windows and you have to like right click to get a menu.
Yeah, it's just like that
or you just get a terminal.
That horrible grid of like black and white dots and your cursor is an X.
Exactly. And you just have a terminal, and I would just type Netscape, and I would get a web browser. Oh, so nice.
Yeah, good old days. Times. So let's say someone, has a website already in JavaScript, and it's using, a bunch of different libraries. It's using, random and using all sorts of different libraries. They rewriting it is totally off the books, but now they need to do something which Clojure is really good at. How does that work? Like, is there some type of interoperability layer?
Yeah. So because Clojure and ClojureScript were designed to be hosted, the interop is just really seamless. You can call, first of all, any function, you can just call it like a JavaScript function. You get a JavaScript function from something, you just call it. If you get an object, like let's say you get a promise, you can just call methods on it, just like normal JavaScript. And you can access the properties too. So the hardest part with the interop is that you're not dealing with JavaScript arrays anymore. You're going to be dealing with Clojure's immutable data structures.
Gotcha.
So you're going to, if you are doing a lot of interop where you're like building up a Clojure vector of data, and then you need to pass it to something that's expecting an array, you're going to have to convert it. And so there's going to be a little performance penalty there every time you convert it.
That makes sense. But I mean, most people use objects. I mean, there are, cases where you need arrays, but that's more rare, I would think.
Mm-hmm. Well, I mean, it's the same with objects. If you're using a plain JavaScript object, just like open curly braces, you're going to need to convert from. So Clojure would, in that case, Clojure would use a hash map, a Clojure hash map. So you would need to convert it to a JavaScript object.
Okay,
which basically requires like walking down the hash map and converting everything into something that JavaScript would use.
Yeah, that makes sense. Cool. So what about, we have sort of a faction of the audience. If faction is faction I feel like faction is a connotatively positive word, but now I'm starting to doubt myself. We have
a portion?
Yeah, we have a portion, we have a section of the audience that's just really into the career side. It's people who want to get into the industry. And so they're, right now they're really wondering what's the job market, or even if they're doing freelance, they want to do freelance work. They're wondering how would this sort of affect my freelance work? Like, does this give me some if I'm given the freedom to use any language, does this boost my productivity? And so what is sort of the on the business end of it, how rich is sort of Clojure right now?
That is a really good question. So I'm going to take it in parts. There's a lot of Clojure jobs out there right now. I mean, it's not JavaScript, right? Because basically every company has JavaScript,
right?
And so if they're going to dictate what language you're going to use, there's much fewer companies that are asking for Clojure script. But they're out there. They're definitely out there, and they're looking for people. I do have to say a couple of things. Because it's a smaller group, it is easier to get into, and it is, I believe, how do I put this? If you have the JavaScript normal curve of like quality of developer, and you have the Clojure script normal curve of quality of developer, obviously the Clojure script normal curve is like a smaller, like tiny little thing next to the JavaScript curve. But the average is higher, because Clojure and ClojureScript are probably not their first language, whereas in JavaScript, it's much more likely that JavaScript is their first language. So even if you just think someone with two languages is better than one, you've got that going for the Clojure and ClojureScript side.
That makes sense. I think there's a lot to be said for joining a smaller community, especially when you're just learning. I mean, there's a lot of resources. There's people who are very passionate about it, and you're not just completely swamped. I mean, if you were to learn JavaScript as your first language and learn it in sort of a professional sense, you're just completely swamped with, as Eric mentioned, just all the different tools, all the different libraries. And it sounds like ClojureScript, with a smaller community, you can really kind of dive deep and get a good understanding.
Yeah, for sure. And it is everyone, or not everyone, I don't know. Many of us have heard this story that JavaScript was actually designed in 10 days, which is kind of an exaggeration, but yeah. It's not far from the truth. Whereas Clojure and ClojureScript have a much richer history, and a lot of design work went into it. So you can it's palpable when you're programming in it that things were thought out much more than in JavaScript.
Yeah, and I think things are starting to trend in the direction of more fully featured languages. I mean, if you look at Haskell and Scala, for example, they have type inferencing, and the browsers now are more sophisticated, so you can see the inferred type. And so, a combination of the browser and the tooling getting more sophisticated, and also the projects just becoming more complex, it sort of dictates, languages that are more, principled. And so that's one of the reasons why there's just so many alternatives to JavaScript, like so many different ways you can write JavaScript, because people just can't get by with native JavaScript when the project gets very large and complicated. And so, yeah, I think ClojureScript would be a great first thing for people to learn.
Yeah, I mean, I just did a workshop and we did ClojureScript. And a lot of them were first-time programmers. And it went well. The number of things we had to install, I think we had to install 2 programs on their computer. We had to get the JVM on there because the ClojureScript compiler does run on the JVM. It's written in Clojure. Mm-hmm. And then we had to get Leiningen, which is the Clojure project management tool. And with those two things, like, you're done. Like, even the editor, this is really crazy, but there's an editor called Nightlight that is just a plugin for Leiningen. So it runs, like, you just type line Nightlight and you get an editor that, you open your browser to a certain URL and you've got an editor editing the code in that project.
Oh, nice. And
you got live reloading with another plugin. So you're typing and, like, you can see the change in your browser. Like, you can see the effect of that. And so it's just an amazing experience that someone can type a couple commands at the terminal and get this development experience going.
Yeah, very cool.
Yeah. Now, you mentioned freelancing. So that one, I think, is probably where you're going to see the most bang for your buck. Like, if you really can choose whatever language you want, which I think is the case in a lot of freelance situations.
Yep.
I mean, it is it's so much better than JavaScript in my experience. Like, if I was going to do freelance, I would do Clojure and ClojureScript, no doubt.
Yeah, and you can definitely do some pretty sick arbitrage. I mean, if there's a project where ClojureScript would make this so much more efficient, but the person expects you to be writing this in JavaScript, you could actually do it twice as fast. So.
Yeah, exactly. And like, I've been waiting for a little bit, like a couple years now. But with React, so we've heard that React is functional, right? Well, when you have a functional language and a functional framework, it just works so well together. The React wrappers in ClojureScript, there's actually several that are popular. But the React wrappers make it so nice. Like, a component is just a single function. And, I mean, you can do all the lifecycle stuff if you want, but mostly you don't need it. And you keep your state in an atom. And it's just so clear, like, how your UI is changing based on the state and like adding stuff to the state, removing stuff from the state, changing the UI. Anyway, it is such a nice development experience that I've been expecting someone to, like, sweep a hackathon, just like do something amazing in 48 hours that no one else would believe was even possible, because they were using ClojureScript. Nice. I've been waiting for it to happen, but I haven't seen it yet. So
cool. Only a matter of time.
Yeah, maybe because the ClojureScript. So I don't think I've done it enough justice. So not only is the development experience great, where you have, like, live reloading, and when I say live reloading, it doesn't mean, like, it just refreshes the browser automatically. What it means is your app state is still there, but the UI, like, you've changed your UI code. And so you could be, like, a few clicks in, like you're testing out your
you
app,
have an email app and the email is half written.
Right. And then you're like, ooh, that component doesn't really look right, or let me add bold to this toolbar, whatever. And you just add the code to add bold to the toolbar, and boom, the component just changes, and the email text is still in there.
That's awesome. Yeah, when we explained functional languages 3 years ago now, we told people, a lot of people say, oh, I've never done functional programming. And what we've told people is, actually, yes, you have, and probably your parents have too. It's called Excel, right? And when you're using Excel and you type a formula, and then you paste some data, and just kind of magically, and as you're changing the formula, the spreadsheet is just changing, and it feels so kind of alive and magical. I mean, It sounds like with with ClojureScript, you get that same feeling, but with web development.
Yeah, for sure. And you go back to where you have to reload and then like click through a few things to open the thing back up that you were looking at to make sure that you did it right. And then, I didn't do it right, or I want to change the styling a little bit more, and you have to change the code and then reload. And like I have no patience for that anymore. I've been spoiled.
That makes sense. So if someone wants to learn Clojure, what's sort of the best, way that they can get started?
Oh, good question. There's a lot of books, but I'm actually going to take this as a cue to plug my stuff. So I've got purelyfunctional.tv. There's 150 something videos on there.
Oh, wow.
Of varying length. And most of them are like behind a paywall, but there are some things that are available for free if you want to just test them out and see if you like it. There's one called Intro to Clojure, and that's not ClojureScript. It's regular Clojure. But it's the same syntax, same data structures, same core library, so it'll help you on your way. And also, I've got a page set up, purelyfunctional.tv/throwdown, and I'll give you a nice coupon code for a discount on a subscription.
Oh, very cool. So yeah, just to recap, if you go to what was the first part?
Purelyfunctional.tv.
Purelyfunctional.tv/throwdown. I'm assuming all one word, no hyphens or anything.
Right.
Yep. So purelyfunctional.tv/throwdown. If you go to that URL, you actually get a discount for some of the premium content on the site.
Yeah. And get in touch with me. My email is eric@lispcast.com. I love answering email about Clojure. Any questions you have, that'd be great too.
Cool. Awesome. I'm definitely going to check this out. This is super cool. I had no idea actually that Clojure could be used with React and React Native. I've struggled trying to learn React and React Native. I mean, I did learn them eventually, but it was not intuitive. Mm-hmm. And so I'm going to give this a shot and see if it feels more natural. It's weird. I feel as if there are some things like, I'm trying to think of a good example. I think actually JavaScript is one of them. Like JavaScript felt natural to me insofar as when I was doing it, I was just inspired to keep doing it. There are other things, like Scala is a good example where I write some Scala and I just want to write less Scala. and I had to do it for a job, so I kind of powered through it. But and I feel React Native is one of these things where the more I did it, the less I wanted to do it. And I'm gonna try with Clojure, I guess with ClojureScript, and see if it feels more natural.
Well, I actually had the same experience. I was using JavaScript in React Native for a client, and it was, there was just so much to learn. That was the real thing. It's like I want to get something done, but there's all this life cycle things, and a lot of the tooling was kind of weird, and then there was all the styling and the new components that you had to learn.
Yeah.
And then the biggest thing of all, which I don't think we ever solved, I think no one has solved this yet, the routing, which I don't like. I don't do much mobile development. Apparently routing is like really important, and I just don't get it.
Yeah, same here.
But it has to do with like keeping track of the back button, and stuff can slide in from the right and slide in from the bottom, and like you want it when you hit the back button, like you want it to remember the right thing to go to. Anyway, apparently that's a hard problem. And I then was like, well, I got my bearings in the React Native, and that was cool. And so then I tried it with Clojure script, and it was just so fun. Now I didn't make like a complicated app with a lot of screens and stuff, but it actually felt like, wow, I can now make all those little apps that I thought should be easy to do. Like I wanted to make a
tip calculator or something.
Yeah, exactly. Like I want to track I run, so I want to track my runs, and I use Runkeeper, but it's like overly complicated for what I need. I just want something like I click a button and I start running, and that I did it, and it's so nice. So I'm actually making a course about that app that I made.
Cool.
I've given a talk about it, and yeah, it's a really simple app you can make, and it shows off how nice that live reloading is. So you're tweaking the UI, and it just magically changes in your little iOS simulator.
Very cool. So yeah, I think that kind of wraps it up. So Merry Christmas, Happy Kwanzaa, Happy Hanukkah, other things I might have missed, because this episode will probably go out, around that time. Have happy holidays and all that. Thank you everyone out there for supporting the show. Thank you, Eric, for coming on the show and explaining Clojure to us. And we really appreciate your time. There's do you want to give a shout out to the link one more time so people can get that discount?
Yeah, purelyfunctional.tv/throwdown.
Cool. So there it is. And have fun. Happy hacking. Hopefully you have a cool Christmas project. Like Patrick's probably going to build, as I said, some robot that will terrorize his neighborhood.
I feel like you're just going to make the feds show up at my door.
Yeah. I don't really have anything in mind, but actually, I do plan on doing a lot of drawing. I wrote a script for a game, but this is like a role playing, like one of these RPG games where it's a lot about kind of dialogue and characters, and so now I want to actually go and draw all those characters. I think I'll probably make that my Christmas project. But whatever your project
really
is,
cool. Get away
have
from the
fun
computer.
And have a happy Christmas, and we'll see all you listeners next year.
The intro music is AXO by Binar Pilot. Programming Throwdown is distributed under a Creative Commons Attribution Share-alike 2.0 license. You're free to share, copy, distribute, transmit the work, to remix, adapt the work, but you must provide attribution to Patrick and I, and share alike in kind.